Okay, so we're back, and I wanted to offer you a quadratic function that was a little bit more challenging. You'll notice that the values that we kind of solicit from this function will be messier, so to speak. So it's the same 8 questions that we answered before, that we kind of worked through before, hand in hand, but the function has changed. It's now b of x is equal to 3x squared plus 3x minus 4. So slightly different situation. And again, probably the best thing you can do is to pause this video, see if you can answer all these questions. You're familiar with them now. And once you have, and you want to get some confirmation, then just resume watching it. So here we go. Does the graph of the function open up or down? And how does the equation reveal this to you? This particular equation's graph opens up. We know that because the sign of the quadratic term right here, or the leading coefficient. So leading coefficient just means if you have your terms in order in this particular problem, this polynomial we call it, where the x squared is followed by x to the first, and this effectively has no x at all, this would be called the leading coefficient, or you could call it the coefficient of the quadratic term. It's positive. This graph opens up. What do we expect it to have? We expect it to have a minimum value because it's a u that's opening upward. Third question, where is the equation for the axis of symmetry? Here I am using that familiar x is equal to negative b over 2a, which we can derive this, by the way, when I come back if people are interested in where this comes from. But for now, know that it's a tool that works consistently. This is an algorithm. It's just a formalized series of steps that we follow. So I'm looking for the opposite of the b term, which is 3, over 2 times the a term, which is 2 times 3. We're looking at negative 3 over 6. We've got ourselves a fractional answer. The axis of symmetry is the equation x equals negative a half. Question 3. I'm sorry, 4. What is the value and what is the point? Well, here we go again. I'm going to take that value that represents not only the axis of symmetry, but where, in fact, the vertical line, that axis of symmetry, passes through the vertex and give, that negative 1/2 to the function. So I'm finding b of negative 1/2. You may want to take your time kind of looking through these computations. This is even if you're in a really higher level math course, you're going to have to confront some computations. So being able to square negative 1/2 to get a fourth, multiply 3 times negative 1/2 to get negative 3/2. By the time I get here, the denominators aren't the same, so I'm giving them a common denominator. Finally, I get an answer of negative 4 3/4, which I can also represent as a decimal, negative 4.75. And that represents the minimum value that the function produces. The minimum point, by contrast, is negative a half, comma negative 4 3/4. I could have represented this as a decimal if I chose. They're both equally as valid as one another. What's the y-intercept of this function? Again, you want to let the input equal 0, because if your input or your x value is 0, then you're on the y-axis. So b of 0 kind of kills off the quadratic and the linear term, leaves us with negative 4. The following question is, what's the vertex of the function? We'd already reported that earlier. We just didn't call it the vertex. We were calling it the minimum point. So again, and this time you'll notice instead of a fraction, I just feel like reporting it as a decimal. They are both, again, equally valid representations of the answer, negative 0.5 and negative 4.75. If you graph this vertex, notice I'm at negative a half, negative 4 3/4, and you graph this y-intercept, 0, negative 4. And again, let me be careful. Not really graphing, rather sketching. I don't have many points here. This is not a legitimate graph. I want to be very clear about that. But this sketch reveals to me that, once more, I'm going to pass through all 4 quadrants. Certainly not all parabolas do, but the 2 examples that I've worked through happen to do so. And finally, what are the domain and range of this function? Once more, the domain is all real numbers in interval notation expressed as from negative infinity to infinity. Pardon me. And the range is from negative 4.75 down here at its minimum value up towards infinity, certainly never reaching it, which is why we have the parenthesis. And as I did previously, we can also look at the graphing calculator. Let's do that. We don't have to go back to the 8 questions. Let's just kind of play with this here. When you first press graph, it's a decent graph. personally, I would like it to kind of open up a little bit more. There's a lot of what I kind of refer to as dead space here, a lot of negative x and positive x values that I don't really need. So how about we go from -6 to 6. That kind of creates a crowd that's a little bit smoother. Let's improve on that a little bit more. Let's not be impatient. How about we do a -6 here and cut these down even further. How about -5 and 5? And I should really see a significant improvement in terms of quality, and I do. So if I'm interested in finding this minimum value or minimum point, how do I do it? Second function button, the blue button, lets you access all these blue keys here, and I'm going to calculate, in this case, the minimum. I'm going to make sure I put constraints. Notice my cursor is blinking to the left, and then consequently to the right of that minimum. And here's that confirmation. This is pretty much -0.5, that -1/2 that I found, and -4 3/4. So that's the confirmation we wanted. We can see here clearly that it opens up, that it goes through all 4 quadrants. If I'm interested in this y-intercept, once more I can go to the table. And there we are, at 0 I have -4. I think I went over this in one of my Edpuzzle videos, but if you should ever want to change the table settings, you would press the second function button, and right above the window key is a table settings button, and you can dictate where the table starts. You can also dictate the delta in the table, the changes. So you might say, well, I don't want to see what's happening every 1 unit of change. I want to see what's happening every 0.5 units of change, and you can do that as well. I hope this was enlightening. I hope that, even when a function is so-called messy, you feel comfortable analyzing it and figuring out how it's behaving. Again, thanks for your patience. Thanks for kind of coping with the coughing and the sniffling. And I do hope to recover and be back soon. Take care now.